So I just wanted to take this time to talk about some basic geometry terms, because terms are very important in geometry, because if you don't know what they are, you're not going to know what I'm talking about in the actual main lessons here. So I just wanted to review some of these with you, just to make sure we're all familiar with those. So geometry takes place in space, and space is just anything with quantifiable direction, essentially. And that can be described in a number of dimensions, and dimensions just separate the number of directions you can have to describe space. So in one-dimensional space, so just 1D, that's described as just a line. You can go left and right, forward and backwards, and that's it. So that's the first dimension. Then there's two-dimensional space, which takes place on a plane, which is just a flat surface that goes on for infinity. It goes up, down, left, right, forwards, and backwards, and you can have any number of different diagonals and angles here. So it's a flat plane that goes off in every direction. And then the last dimension that we'll use here is 3D, and that's going to be kind of hard to draw here. But 3D takes place in what is also known as just space. You can go forward, backwards, left and right, up and down. It's like having the coordinate directions on a compass. You can go north, south, east, west, up, down, and any angle in between. You can go northwest and slightly up, northwest and slightly down, northeast and slightly down, northeast and just flat. So, and this of course goes off in all of the directions as well, any diagonal direction you want here in 3D space. It also goes to higher dimensions, but that's really complicated stuff, and we won't get to that here. But those are dimensions. I do want to define the line, though. The line has no thickness whatsoever. It only has direction in left and right, which is what I described one dimension as. It goes on forever, unless it is segmented by points. So this could be defined as line AB, if it has points A and B on it. So this entire line could be line AB, and then that section of the line between lines A and B is segment AB, and is notated as such. You describe a line by the points on the line. A ray is a segment of a line that just has one endpoint and goes on forever. So this would be ray A, and you notate it like that. The midpoint of a line segment, so say we have segment AB. Say we have midpoint C here. Now this is a midpoint if it cuts AB into two equal parts. So that is the length of AC equals CB. And that segment AC is congruent to CB. And congruency means that they have the same length and they look the same, essentially. They have all the same parts. So you notate segment like with that little line there, and you notate the length of the segments with nothing else. You just write those values there. They're not variables. That just is to denote what segment you're describing in length. So midpoint cuts it into two even segments. You can have a plane, back to the plane, and the plane can be described in a lot more ways than a line, because you have a lot more space to work with. We usually describe the plane using a coordinate plane with an x and y axis, and then we denote points based on their distance from the x and y axis. You can also just use a letter too. A plane can also be notated by the points that it has. So say we have a plane here, and of course this would go off in any direction. Sorry about the bad drawing, but this would go off in any direction here. And say we have points A, B, and C. You'd say that this is plane A, B, C. The same deal with space. You can denote space with multiple points. A point itself is technically zero-dimensional because you cannot be defined using any direction. So point A here would be zero-dimensional. To define a line, you need 2 points, because you need a line to connect the 2 points. That was a bad line there. You need a line to connect the 2 points, and a space is defined using 3 points, because if you have 3 points here, they're not on the same line. You'll notice you can't make one line connecting all of them, but you can make a space connecting all of them, or a plane. Sorry, you can make a plane connecting all of them. So it takes 3 points to denote a plane, and it takes 2 points to denote a line. Then there's also angles. Angles just measure the distance between 2 lines here. And the angle is denoted in figures like this, with that little curvy line there. And angle's units are defined in, we'll define them in degrees, and a degree is just 1/360th of a circle. So if I draw a circle here, and you have a center here, all of that possible angles that you can make here, we define them as having 360 degrees. So one angle is 1/360th of a circle. The reason it's 360 is because it was developed by the Babylonians in ancient times, and they used a base 60 number system. That's the reason why it's 360, if that seems like a random number. There are different ways to determine angles. There's acute angles, which have measures of less than 90 degrees. There's right angles, which are exactly 90 degrees. And you have a little square there if you want. Right angles, you could also use the curvy there. And then there's obtuse angles, which are more than 90 degrees. And then technically a straight line is a 180 degree angle, because if you, again, go back to the circle and you draw a straight line, it's dividing the circle into halves, and half of 360 is 180. So a straight line is technically a 180 degree angle. There's different relationships that an angle can have. If 2 angles are next to each other like this, so we'd say that angle ADB is adjacent to angle BDC, because they're right next to each other and they share a ray here, because technically these lines would go out for infinity, so they share a ray. That brings the notation of angles. So say we have an angle with points A, B, and C on it. A, B, and C. You always put the center point of the angle in the middle of the other 2 points. So this is angle ABC. So like, say if this was angle C and this was angle B, you would change this to be angle ACB. So whatever the middle point is in the angle is the middle letter in naming the angle. And that may seem really dumb and unimportant now, but when we get into problems involving angles and you won't know what some of the other lengths and positions are, that'll be extremely important in helping you figure it out. So make sure you always notate angles like that. But yeah, adjacent angles, they share a ray. Vertical angles, so you'd say that these 2 angles are vertical because they share a vertex, and a vertex is just a point on a line or on a shape. So they share a vertex here, so they're vertical angles. And vertical angles are always congruent, meaning that they have the exact same value. So if this is x degrees here, this is also x degrees. So they are always the same. Also, these 2 angles here would also be congruent. Angle, we'll just call it y degrees. So those would also be congruent. You'll notice that they all add up to 360 degrees together. So, yeah. And then there's complementary angles that add up to 90 degrees. So like these angles here would be complementary because they add up to 90 degrees. Supplementary angles add up to 180 degrees. So this angle and this angle add up to 180 degrees because they form a straight line when they are adjacent. Lines can also have relationships. Lines are parallel if they never touch each other in space. When they're on a coordinate plane, like the XY plane that you're familiar with, that means that they have the same slope. Perpendicular lines form a right angle at their intersection. A bisector is a line that cuts a segment or angle in half. So say we have an angle here, and then we have a bisector here. It would cut this angle into two smaller congruent angles if it's in fact a bisector. You can also intersect a line to form it into two congruent sections there as well. A polygon is just a closed figure made out of lines and angles. It can have 3 or more sides. Anything smaller than 3 sides isn't technically considered to be a polygon. It also has to have straight lines. It cannot have curves for sides. So like a triangle would be a polygon, a square, an octagon. All of these are examples of polygons because they're closed figures with lines and edges. That's a really bad octagon. I apologize. A polyhedron is just the 3D equivalent of a polygon, so it's made of is a closed figure made of planes, lines, and points and angles. So like a cube would be a polyhedron, and like any sort of like a cylinder would be a polyhedron. I'm not going to draw a cylinder because it's going to look really bad, but a cube would be a polyhedron. I'm going to talk more about the polyhedron. Have some really interesting properties that I'm going to go into more probably in the second part of the area and volume formulas lesson, like working with like their bases and things like that. You'll notice that polygons are 2D figures and polyhedra are 3D, and a polygon is made up of less than 2D components. So it's made up of, lines and points, which are 1 and 0 dimensional components. So an n-dimensional component or an n-dimensional figure must have components that are less than n. So this is 2D. It must have less than 2D components. I'm just gonna write that there so you remember that. The same deal for like a 3D shape. So a cube is made out of 2D squares and 1D lines and 0D points. So that's a 3D figure made up of less than 3D components, 2D, 1D, and 0D ones to be exact. The last thing I'm going to talk about is diagonals. So if I have a square here, a diagonal is really just anything that connects between two angles in a shape. So like that would be a diagonal in a square. In like a pentagon, this is going to be a really bad pentagon. So like in a pentagon, this would be a diagonal, or this would be a diagonal, or this would be a diagonal. It's just anything that connects two angles in a in a polygon, or in a polyhedron too. It can work there too. What you'll notice is that the diagonal bisects each angle that it touches. So that's just an important property of diagonals. They bisect their angles, so that means that these two would be congruent. These two would be congruent here, and so on. If I forgot anything, I'll just mention it as I go along in each of the lessons, because it shouldn't take that long to just explain like one additional concept. I know I went kind of fast there just to try and get everything in, but if there's something you're confused about, please feel free to just ask a question in the comments, and I'll be sure to answer those if I see any. So thank you very much. I hope to see you in the formal geometry lesson videos.